Bismillahirrahmanirrahim. In this video, we'll try to understand the maximum average power transfer, and also we'll discuss example 11.5 solved in the book, and we'll solve practice problem 11.5. So let's understand the concept of maximum average power transfer. Finding the maximum average power which can be transferred from a linear circuit to a load. So if this is a linear circuit and this is a load, we need to find the condition for maximum power transfer from the circuit to the load. And so first of all, we represent the circuit with the Thevenin's equivalent. So this is the circuit, and then we can find the condition for the value of ZL and also the power consumed by the load. Now, load ZL represents any element that is absorbing the power. So this can be either a motor or a TV or a toaster, but this should be capable of absorbing power. So that is the first condition. And we are interested to find the value of ZL, which will ensure the maximum average power transfer from the source. Now, to understand the concept, let's start with we converted the source with Thevenin, or the linear circuit with the Thevenin circuit, and then connected the load. And now we can divide the impedance in terms of a resistive component and reactive component. So Z Thevenin can be written as R Thevenin plus JX Thevenin, and similarly the load impedance can be written as RL plus JXL. Now for maximum power transfer, the derivation I am omitting, this is in the book, you can go through, but simply this has to be equal to this, that is RL has to be equal to R Thevenin. RL has to be equal to R Thevenin for maximum power transfer, and similarly XL has to be equal to minus X Thevenin. So minus X Thevenin, so important to note this. And therefore we can say that since ZL is equal to R plus JXL, and replacing R by R Thevenin and XL by minus X Thevenin, this will become equal to Z Thevenin conjugate, because the sign has now changed. You see, Z Thevenin was R Thevenin plus JX Thevenin, but here it is minus sign, so it will be Z Thevenin conjugate. And therefore we can say that ZL has to be equal to Z Thevenin conjugate for maximum power transfer. And if you recall from the DC circuit, we had found that for maximum power transfer, RL has to be equal to R Thevenin. So this was for the case of a DC. Now this is for the case of a AC. Okay, so we found the condition for the maximum power transfer. Now we need to find the amount of maximum power. So for maximum power, or the amount of maximum power, we write VAV max, and that can be found if you can find the current through this circuit. So current is V Thevenin divided by Z Thevenin plus ZL. So V Thevenin divided by the two impedances will give the current, and the average power delivered to the load will be given by this formula, half I conjugate square. So the conjugate of this current into RL. And now putting in the values, we arrive at this point, and then setting R is equal to R Thevenin from this. So R is equal to R Thevenin, and X is equal to minus X Thevenin here. So this will become 0, and simplifying, we get the condition for P average maximum to be V Thevenin square divided by 8 R Thevenin. So if you solve this by putting R is equal to R Thevenin and this x is equal to minus x Thevenin, this will become 0, and simplifying you get this result. So this is the condition for average maximum power when the load has a resistive element and a reactive element. So let's solve the problem. 11.5, this is solved in the book, so we'll just go and understand. So determine the load impedance ZL, this we need to find out for maximum power transfer, and then we have to find the value of maximum average power. Okay, so the first thing we need to find is Z Thevenin. We remove the load and short circuit the voltage source to find Z Thevenin. I hope you have learned this from the Thevenin's theorem. And now you can see this 4 is parallel into this and then added with J5. So like this. So first of all we solve this into parallel, then we add J5 for Z Thevenin. So Z Thevenin is J5 plus these two parallel, these two arms in parallel, and solving we find this value for Z Thevenin. And now we need to find V Thevenin because we actually need to find the Thevenin equivalent. So for V Thevenin we incorporate the voltage source back, and now V Thevenin is the voltage here. So it is the same voltage that will be across this, because now in this case no current is flowing through this one. So whatever is the voltage here is the voltage here, because there is no voltage drop in this. So by voltage division rule we can find the voltage here. So by voltage division, total voltage divided by total impedance, and multiplied by the arm across which we need to find the voltage. So 8 minus J6, and this is the answer for the V Thevenin. Now we know that the load impedance for maximum power has to be ZL equal to Z Thevenin conjugate. This was what we found to be Z Thevenin, so we just change the sign here to get the conjugate. We have changed the sign to minus, so this is the conjugate. And now we have found the ZL, we need to find the maximum power, so just plugging into the value. V Thevenin, this is the magnitude of V Thevenin, and 8 R Thevenin. So R Thevenin, you can see from here, this is R Thevenin, or this is R Thevenin. So the P max is 2.368 watt. Now let's see the practice problem. Exactly same way, similar. We need to find the Thevenin equivalent first of all. So we remove the load, and from here we need to find V Thevenin and Z Thevenin. So Z Thevenin first. So we remove the source, current source is taken out, and from here you can see Z Thevenin. If we look from this point, these three in series will be in parallel with 5. So Z Thevenin is 5 parallel 8 minus J4 plus J10 on this term, and solving we can find it to be 3.415 plus J 0.7317. So this is Z Thevenin, and V Thevenin will now be the voltage across this. We have incorporated the current source back, so we need to find the current in this arm, and multiply by 5 will give us V Thevenin. So now this you can find this current by the CDR. This is dividing into two paths, so let's apply CDR. So by current division rule, I is the total current divided by total impedance, that is this plus this, and multiplied by opposite arm. We need to find the current in this arm, so we'll multiply by opposite arm. So 8 minus J4. So this is the current, and now V Thevenin, as we mentioned, it will be 5 times I. So 5 times I, this, and solving we find 37.56 angle 51.34 minus. Okay, so now that we have found VThevenin, we are ready to find the value of ZL. ZL has to be Z Thevenin conjugate. We found this to be Z Thevenin, so we change the sign here. So this is ZL. And the maximum power V Thevenin square over R Thevenin, 8 R Thevenin, so V Thevenin. This was the magnitude. So we write that square, 8 R Thevenin from here is 3.145. So this is the answer for maximum power. So I hope this gives you an understanding how to find maximum power and how to find the impedance for maximum power. Thank you. So this is the answer given in the book. So we are very close to the answer given in the book.